Hello, good day, and welcome to Science E-Learning Academy. My name is Malaki. In today's tutorial video, we shall be looking at the Vernier Caliper. In our last video, we treated fundamental quantities and units, and at the course of our study, we learned the 7 basic fundamental quantities, which we made mention of lengths. So we listed fundamental quantities, and we said they include mass, length, time, etc. It is 7. So in today's tutorial video, we shall be looking at measurement, and we shall be looking at how we can make measurements using the Vernier caliper. All right. Physical quantities in physics can be measured. And we say that physical quantities are measurable entities in physics. Then, when you want to measure length, there are so many instruments that you can use to measure length. You can use tape to measure length. You can use the roller. You can use Vernier caliper. You can use the micrometer screw gauge. So all these instruments can be used to measure length, and it is found that the micrometer screw gauge measures length more accurate than these other measuring instruments. Why? It measures length more accurately because the reading accuracy of micrometer screw gauge is smaller than other measuring instruments. So the micrometer screw gauge measures length more accurately than the Vernier caliper, and the Vernier caliper measures length more accurately than the other instruments. So, but in this video, we want to look at the Vernier caliper. The Vernier caliper has 2 sets of jaws, the inside jaws and outside jaws. It has fixed jaw, it has the screw, it has the main scale, 2 sets of scales, the main scale and the vernier scale. This vernier scale slides over the main scale, and the main scale could be calibrated in centimeters or in millimeters. Now, what are the objects that the Vernier caliper can measure? The Vernier caliper can measure the thickness of a meter rule. It can also be used to measure the internal and external diameter of a tube, or the diameter of a rod. So, and as we have said, that in measurement of length, Vernier caliper gives accurate reading of measurement of length more than the roller. So, how do we make measurements using the Vernier caliper? To make measurements using the Vernier caliper, you must ensure or endeavor that the zero of the main scale, this is the main scale, and I've said the Vernier scale slides over the main scale. You must make sure that the zero of the main scale coincides with the zero of the Vernier scale. This is the zero of the main scale, and this is the zero of the Vernier scale. Why must it coincide? You do this in order to make sure you avoid zero error. When you must have ascertained that there is no zero error, then you can now go ahead to make your measurements. The first picture I showed depicts correctly how you make measurements of, let's say, is a round ball. So this is a round ball, and the ball is fixed in between the 2 outside jaws. So this is the screw. You slide it so that it gets fitted inside. So once it gets fitted inside, then you take your measurements. There are some digital vernier caliper that once you have tightened it up to this point, you can take the measurements at the surface. It is calibrated in such a way that once this is inserted, the reading automatically shows here. But in this type of instrument, you are to take the reading yourself. So how do we do it? How do we do it? If you are new to this channel, you help us promote the channel by subscribing, clicking the notification bell. You subscribe by clicking the subscribe button. It is free. Invite your learning colleagues. You can follow us on Facebook. We are virtually at all social media handles. Facebook, follow us on Facebook, Science E-Learning Academy. Follow us on Instagram and TikTok, Science E-Learning Academy. So let's continue. Let's look at how we can now take reading using a vernier caliper. I have brought out 3 examples that will help us take readings or show an example of ways which measurement of length can be done using the vernier caliper. Now, looking at this example, this is a vernier caliper that has the main scale and the vernier scale. The main scale and the vernier scale. As you can see, the main scale of this vernier caliper is calibrated in cm. So the question is, what is the reading of the vernier caliper above? What is the reading of the vernier caliper above? Before we take reading, we solve this problem, I would want to point out that the vernier caliper has reading accuracy. Reading accuracy. And what is reading accuracy? The vernier caliper has reading accuracy. What is reading accuracy of a measuring instrument? The reading accuracy of a measuring instrument is the smallest measure of that instrument. For instance, in the ruler, a ruler is calibrated in this manner. You have, let me calibrate it. Let's say this 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You have 1. You have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. A ruler is calibrated in this manner. So how do you show the reading accuracy of a ruler? How do you show the reading accuracy of a ruler? This will be 2. So we say that the reading accuracy of an instrument is the smallest measure of that instrument. You now see that here is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. So the smallest measure of this instrument is 0.1. It can also be taken as half of the smallest measure of an instrument. But what is widely accepted is that reading accuracy of an instrument is the smallest measure of that instrument. So for ruler is 0.1 cm. So when you talk of the stopwatch is 0.1 seconds. So but in our study today, we are looking at the vernier caliper. What is the reading accuracy of a vernier caliper? The reading accuracy of a vernier caliper is 0.1 millimeter or 0.01 cm. The reading accuracy of a vernier caliper is 0.1 millimeter or 0.01 cm. You can be asked if a vernier caliper is drawn, you can ask what is the reading accuracy of this instrument. The reading accuracy of a vernier caliper is 0.1 millimeter or 0.01 cm. If we divide this 0.1 by 10, so you have it in cm, and if you multiply this 0.01 by 10, you now have it in millimeter. So since this vernier caliper is calibrated in millimeter, you see that the options that we have here, since the vernier caliper is calibrated in cm, you see that the options we have here are in cm. So how do we take reading of this instrument? So to take reading of this instrument, you take the reading of the vernier scale, and add it to that of the main scale. You take reading of the vernier scale and add it to that of the main scale. That is very simple. So how do we go about it? So the main scale is this. The main scale, as I've said, is this. Look at the main scale. So how do we take the reading of the main scale? We take the reading of the main scale just before the zero of the vernier scale. We take the reading of the main scale just before the zero of the vernier scale. So the zero of the vernier scale should be here. The diagram wasn't drawn very well. So the reading of the vernier scale should be here. But since it is since here is taken as the zero, you need to adhere to that. But in some other examples we are going to solve, you will see that the zero will be taken from this point. So don't get confused. So how do we now take the reading of the main scale? So if this is 5 and this is 4, let's check. This is 4.1, 4.2, 4.3. Here is 4.1, 4.2, 4.3, 4.4, 4.4, 4.5, 4.6, 4.7, 4.8, 4.9, 5. So before the zero of the vernier scale is this. So let's count again. 4.1, 4.2, 4.3, 4.4, 4.5. So you have 4.50 cm. So we have taken reading of the main scale. Write it, main scale. So we say we take the reading of the main scale before the zero of the vernier scale, and it is this vernier scale that lies over the main scale. So how do we now take the reading of the vernier scale? We take the reading of the vernier scale where it coincides with the main scale, where it coincides, that is where it joins with the main scale. And let us count. This should be calibrated very well. But looking at the answers we have, let's see if we can get it right. This is 1. There is no place it joined with the main scale. This is 2, no place. 3, 4, 5, 6, 7. I've gotten a place where it joined. The vernier scale joined with the main scale. So the vernier scale is 7. But not just 7. We need to multiply it. Since we are working in cm, we need to multiply it by the reading accuracy of my Vernier Caliper in cm, which we have gotten before to be 0.01 cm. And if we do that, we have 0.07 cm. So as I've said before, the total reading of this instrument will be the reading of the main scale plus that of the vernier scale. And I've gotten the main scale reading to be 4.5 and vernier to be 0.07. So we now have 4.57 cm. See that option D is the correct answer. So how do we take the reading? Reading of the main scale plus that of the vernier scale. And while taking the reading of the vernier scale, ensure that it coincides with the main scale. So of this problem, the problem says that a student used a vernier caliper to measure the length of a small wooden block. The diagram shows an enlargement of the caliper's case. What reading was recorded? We know that if here is 20, here will be 15. So this is 10, 12, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So here will be 15. So before the zero of the vernier scale, here will be 11. This will be 12. So we have before the zero of the vernier scale, the main scale reading will be 12 millimeter. And let's now check where the vernier scale coincided with the main scale. You see that it coincided at the 6. So So the vernier scale now will be 6 times the reading accuracy of vernier caliper, which we said before, is 0.1 millimeter or 0.01 cm. So in this case, we multiply it by the reading accuracy of vernier caliper in millimeter. So what do we have now? We have 6 times 0.1 will be 0.6 millimeter. And when we add it, the total reading will be 12 plus 0.6. 12 plus 0.6 is 12.6 millimeter. 12.6 millimeter. And our answer is in cm. So when we divide this by 10, when we divide millimeter by 10, we get centimeter. So you have 12.6 divided by 10, you have 1.26 cm. So you now see that the reading accuracy of vernier caliper is 0.1 millimeter or 0.01 cm, which helped us to resolve this problem. So the answer to this question is C, 1.26 cm. If you've been blessed by this video, do well to subscribe to our channel and follow us in all our social media handles. Subscribe to Science E-Learning Academy, share our video and invite your friends. Good day and have a lovely day.